So I want to present two examples to you that demonstrate a trickier skill that you are going to need from time to time in this course. The short version is, if you've ever heard of a derivative before, you can't just take a derivative of a function that has absolute value bars in it. Not possible. But it is possible to take derivatives pretty easily of piecewise defined functions. And so the secret here is take a function that looks like this and rewrite it as a piecewise defined function by removing the absolute value bars, so it's going to split into two pieces. And the end result is then you're going to be able to do all kinds of calculus stuff to it, whatever you want. So here's the thing. That expression is what matters. Right now, nobody cares about the -5. He's just going to chill there. He's going to come into play at the end. But what matters is whether the expression that I just circled is positive or negative. That's all I care about. And so here's my routine. I'm asking myself, is that positive or negative? And so I'm writing this. I have the exact expression written above. Every single symbol copied. You see the -5? I told you he was going to chill there. There he is. The only thing I changed here is that the bars turned into parentheses. You see that? That's the only thing I changed. The other expression I'm going to write is the exact same thing, except instead of just parentheses, it's parentheses with a minus. So my recommendation to you, if you're going to use this tricky trick, is that you use the parentheses every time, even if you think the function's easy. You don't want to screw up and forget to distribute the negative over the -5x and the +6. So those parentheses can really be a helpful visual for you, keeping your signs straight. Okay, so when do these two expressions come into play? I'm going to use this expression when the stuff in the bars is positive, right? I mean, think about it. The absolute value of 10 is what? 10. Absolute value of 12. 12. Absolute value of a positive thing, that positive thing. You're like, whatever, you don't have to do anything, just take away the bars. So that's exactly what's going to happen here. If the stuff in the bars is positive or 0, all you got to do is take away the bars. And so that's exactly what this expression is telling you. Take away the bars. On the other hand, what is the absolute value of -5? Positive 5. The absolute value of -10? Positive 10. If you're taking the absolute value of a negative number, what you do is you take the negative away or add another negative so that they cancel. So that's why we've got this. So if stuff in the bars is negative, you write this. Now it's all over but for the simplification. In order to simplify, what I'm going to do is write this little number line, and I've already got all the answers written down on here. So what I'm doing is I'm solving for whether x squared minus 5x plus 6 is greater than or equal to 0 or less than 0. And so what's going on here is you factor out x squared minus 5x plus 6 into x minus 2 and x minus 3. And that's going to be set equal to 0. And so that's how I knew to mark +2 and +3 on my number line. And then what happens is I look at all the regions that I've cut the number line into, okay? Region 1, region 2, and region 3. And what I do is I plug in test values into my polynomial and figure out, do I get something positive or something negative? And so grab any test values you like. Do not grab 2 or 3. Grab 1, 2.5, and 4, I think are the best ones. And you plug them into the quadratic and find out if you get a positive or negative. And so these are my results, plus, minus, plus. Additionally, when I plug in 2 or 3, I literally get 0, right? So actually 2 and 3 are going to be included in the first pile of numbers. And so here I go. 2 steps. The first step should be pretty obvious to you. I'm going to remove those parentheses and combine the +6 and the -5. So there's my +1. And I know that if x is over here, or if it's 2 or 3, then I'm supposed to use this formula. So that's why I have it written like this. If x is less than or equal to 2, meow, or if x is greater than or equal to 3, meow, then I'm going to use that formula. Otherwise, between 2 and 3, I'm going to use the other formula, distributing the negative and combining with the -5, and I get a completely different quadratic. And so this is the function expression that I want to do calculus to. Okay, so here is a second example. Tricky, tricky, tricky. I've got two sets of absolute value bars. Absolutely gross. And I want to know where it's increasing, and we're not doing derivatives yet, so we have to do this in a different way. Now what's going to happen is we're going to remove the absolute value bars, and we're going to actually draw this function. What's going to happen is the functions, the pieces of the piecewise function are not going to be so bad to draw, so that's what we're going to do. Okay, check out what's going on here. What I care about, I said we care about the stuff inside the bars, right? So I care about whether this stuff is positive or negative, but now I also care whether this stuff is positive or negative. And it could possibly be that one of the stuffs is positive and the other one is negative, so I need to worry about that. So there's really going to be four cases here. One is if x plus 4 and x minus 4 are both positive, and so all the bars would just disappear. Like, for example, what's g of 5? If you were to plug positive 5 into g, you get two positive numbers here, right? It's like a total joke. But there's three other cases. One case is that the x plus 4 expression is going to be negative, and so you need the minus sign, and that this expression is positive. It could be that the x minus 4 is negative, but this is positive. It could be that they're both negative. So I've got these four cases. And I can pretty cleanly express when I'm going to use these four function rules. If both the expressions inside the both sets of bars are positive, I use this first rule. If the left expression is negative and the right expression is positive, I use the second rule. If x minus 4 only is negative, I use the third rule. And if they're both negative, I use the fourth rule. Just like that. Okay, except nobody really looks at piecewise defined functions like this would be considered kind of ugly. So some simplification is needed. Like last time, the simplification of these expressions is a total joke. The problem is what's going on over here. And so what I'm going to do as a visual aid is I'm going to draw a ginormous number line. And I'm going to label positive and negative 4 on it. And I'm going to look at these three regions and I'm going to think about whether x plus 4 and x minus 4 are positive or negative. Now, over here, to the left of negative 4, can you see that x plus 4 is going to be a negative number always, and x minus 4 is going to be a negative number also? So I'm going to call that region 1, and when x is in this region over here, we're going to use this bottom rule right here. So all of these x's go with this formula. In the middle here, between negative 4 and 4, it's the case that x plus 4 is actually going to be positive now. It switches from negative to positive. But x minus 4 doesn't change. It's still going to be a negative number. And so if x is between negative 4 and 4, I'm actually going to use the third rule. Okay, so those two are going to match up. And finally, over here, I have, for big x's above positive 4, it's going to be the case that x plus 4 and x minus 4 are both greater than or equal to 0. And so I'm marking that like the third interval, and that actually goes with the top rule at all. You know what this means? And this is a really weird reality. That rule doesn't get used at all, but think about it. Think about a number. Is there a number anywhere in the world where it's higher than positive 4 and it's lower than negative 4 at the same time? Doesn't that sound stupid? You can't be above 4 and below negative 4 at the same time. So that formula actually never gets used. So I'm just going to cross it off. All right, I'm ready to go. I'm ready and raring. So I need to think real quick about negative 4 and 4. And so it's the case that when I plug in negative 4, that it goes with these two intervals here. X plus 4 is greater than or equal to 0, x minus 4 negative 0. And positive 4 is going to go with these two intervals here. All right, I'm ready to go. Here is the function expression unsimplified. I know my intervals. I'm ready to write a simpler version of g. Like I said, the formulas simplify real easy, right? You know how to distribute this and combine. I get 2x, and that is if x is greater than or equal to 4. Next, I simplify this expression right here. It simplifies to just 8, just a horizontal line. And that rule gets used if x is in between negative 4 and 4. And do you remember how we said that negative 4 would be counted in this pile, but positive 4 wouldn't? Finally, this expression simplifies to negative 2x, and that rule is going to get used if x is less than negative 4. Okay, so if I draw this real quick, and this ain't so hard to draw, right? Here's 4 and negative 4. I got my 3 zones here. A line is going to get drawn here, a horizontal line is going to get drawn here, and y equals 2x is going to get drawn here. So there is y equals 8. Here is y equals negative 2x, and there's y equals 2x. There's my full and complete graph of g. Boom. So I've done all this work. I've graphed g all the way, and then I ask myself the question, where is g of x increasing? Here, it's increasing right here. So my answer is 4 to infinity, and I'm finally done with this question.